Okay, today I'm going to demonstrate how to do a pin rivet. I also call it a simple rivet. What it is a way to connect two pieces of material, whether they're pieces of metal, they could be pieces of wood, they could be wood to metal, acrylic, it doesn't really matter what the material is. The benefit of using rivets is that you can put these things together without using any heat. These are cold connections. Typically when we're making jewelry, we are soldering pieces of metal together. And if you're using other pieces, other things that can't tolerate heat, rivets are a great way to put things together. But you can also put pieces of metal together as well. So there's 4 different styles of rivet that I use. In this demonstration, I'm just going to show the simple rivet or the pin rivet. This is what it looks like. What we have here is we have 2 pieces of copper that are held together with this pin. This is a piece of brass. It's a piece of brass wire that goes through a hole, corresponding holes in each of the pieces of copper. And those, the heads of that wire are then hammered over, peened out so that they expand on either side, kind of mushrooming out to capture the 2 pieces of copper. The fact that you are drilling a round hole for a round piece of wire allows for movement if you want or need moving parts. This is one way to achieve that. If you want them to be stabilized so that they don't move, you might have to do 2 rivets. So that way there's no pivot point, okay? So the way this works is you obviously have to drill a hole in each corresponding piece of material. These are just scrap pieces of copper. And I have some 12 gauge wire. This is 12 gauge brass wire. You could use, doesn't matter what type of material, could be silver, could be copper, could be brass, could be gold for that matter. But the size, the thickness of the material does matter. So I wouldn't use 18 gauge or thinner. There's just not enough structural integrity to the wire to withstand the pounding or the peening over of the head. Typically what happens is if the material is too thin, if the wire is too thin and you've got it kind of protruding out the end or out the hole, when you start to hit that, that head is going to kind of go over like a staple, okay, as opposed to mushrooming out in order to capture the 2 pieces of metal. Likewise, if your pin is too long, if there's too much material hanging up there and you start to hit the head up here, that can also create that stapling effect, okay? So the length of the rivet is very critical. So I've already drilled my holes. So I'm going to take this piece of wire and push it through. And the tolerance that you have makes a big difference too. You don't want these holes to be big and sloppy, okay? This wire has really nice tight tolerance going through that piece, that hole. And I'm going to push it through the second one here, okay? So now I've got, you can see here, I've got wire protruding out this end here and then quite a bit more over here. We need to trim that down. So how long does that pin need to be? You could do a couple of things. You could actually measure the thickness of the 2 pieces of material that you're riveting together and then add whatever amount you need. That's one way to do it, and that's maybe a good safe way to do it. I typically just eyeball things, but either way, what I shoot for is I try to have about 1 millimeter to 1.5 millimeters on either side of these 2 pieces of metal. That gives me enough material to hammer and spread open and mushroom out so it would capture those 2 pieces. So, with that in mind, you could measure your 2 pieces of material and then add 2 to 3 millimeters and then mark it and cut there. Another way to do it, this is kind of the way I like to do it, is just guesstimate 1.5 millimeters or so on this side. And I'm just going to score a line on this side using my jeweler's saw. and then I will cut that all the way through. Okay, so maintaining my 1.5 mm on that side over there, I'll just score a line here. Okay, so probably a little tough to see. Here's my 1.5 mm. There's my scored line over here. Now I could pull this all back out and then just continue to trim that off. A nice little trick is to listen for the tone to change as you're cutting through this material. You'll hear the pitch rise, and then when you're almost cutting through the material, it'll actually drop. Okay, so let's listen. You can actually hear it dropping. I didn't cut that very well, but you could hear it start to drop, and I could feel it. And so at this point, I can just snap that off. That way I maintain control of my piece the whole time, and it doesn't go bouncing around down below here in my bench. If you do break that off, there's always going to be a little bit of a burr from where you snapped it. So it's good to try to remove that. I see the sun is coming into play here. All right, so let's take this pin, push it through, get it into place. Okay, so here is my rivet on both sides. We can see that protrusion on both sides, approximately the same amount. Okay. Next thing we need to do is have an anvil surface. I just happen to have one here on my bench pin, and I can use that to start to peen the head of that rivet. So the hammer that I'm going to use is a ball peen hammer, okay, something like this. And we will just start tapping the head of that rivet, and that is going to mushroom out that head. So if this is my rivet standing tall here, when we start hitting that surface, it's going to start to open up and mushroom out, capturing that material that's in here, okay? So let's just start this. And a little trick that you can use, you want to maintain the protrusion out the back side or the bottom side. You want the head of that rivet on the anvil surface, but I don't want that material resting flat on the anvil. So a little trick that you can use is you can take a piece of sheet metal that's roughly 1 millimeter thick. Maybe it has a nice hole in it here like this one does. And I can place this down here, push that rivet head down so it's actually touching the anvil surface through the hole. The thickness of the material is supporting the two pieces of metal that I'm trying to rivet together, and maintaining that amount of rivet hanging down. So I'm going to tap this side a few times just to start spreading that material. So now that head won't go through that hole anymore, okay? So it's been spread open just enough to capture the rivet on this side. It hasn't been captured over here, so I need to start hitting this side as well. And I need to work back and forth. Okay, so now I can get rid of this spacer, and I've peened both sides, and that has done just enough to capture these two pieces of metal. They're never coming apart again. They do still move, okay? They haven't been peened over so much that they're locked down. And realistically, the fact that we're using a round rivet in a round hole, capturing these two pieces of metal, that's always going to act as a pivot point. So if you absolutely do not want these pieces to move, you might need to use two rivets like this. Okay, so these can no longer spin on that axis point. Okay. But I'm going to peen these down just a little bit more. be a little bit careful not to hit the surface of your material. If you want that to be really smooth and possibly polished, if you happen to miss and hit your surface of that metal, it's going to leave a mark. So you have to be a little bit careful about that. You could potentially tape that surface. Doesn't necessarily prevent the surface from getting dinged up. But if you're really worried about it, you may consider texturing that surface. If you do a hammer texture in particular, anytime you miss, the impact that you create on that surface is just going to blend in with the hammer texture. So we can peen this down just a little bit more. And what I do is I start hitting kind of in the middle of that rivet, and then as it mushrooms out, I start to work around the perimeter to try to push that down to the surface. Rivets like this can create kind of a sharp edge where the head starts to mushroom out. And if you try to work that perimeter, you can actually push that down just a little bit and have it not be so sharp. Okay, so there it is. There's my my pin rivet, or my simple rivet. Okay, really simple to do. As long as you don't make that rivet too long, it's pretty easy, and as long as the tolerance in the hole is correct, then there's really nowhere for that material to go other than to mushroom out. And there is our simple rivet.